All right, in this lesson, I wanted to offer a quick introduction to blocks in Ruby. A Ruby block is a grouped collection of Ruby statements that immediately follows a method call. So a block is one of the few exceptions to the general rule that everything in Ruby is an object. A block is not an object. It's sort of like an add-on to a method call that clarifies how that method should operate in regards to a specific detail. So a block cannot exist except for within the context of a method. So blocks add a little bit of clarity whenever a method requires a little bit more detail. Now, this can be a fairly difficult concept the first time you see it, so rest comfortably. As we proceed throughout the course, we're going to have plenty of practice with blocks. The purpose of this lesson is to give you a general idea of how they function and what purpose they serve. We're going to dive into them in much greater detail as we proceed and as we get more practice with them. So again, a block is not the same thing as a method. A method is a message that we send to an object, but a block is attached to a method call to an object. For example, let's say I have a fixed num object here like 5. 5 is a basic integer, a number, a whole number. The fixed num includes a available method called times, right? It's just like any other method like next, except this method is called times. And what this method does predictably is execute a certain process a certain number of times, whatever the actual number or object that the message or method is called on. So if we call the times method on 5, we're going to do some kind of process 5 times over. If instead we call it on a fixed num like 10, that means execute a specific process 10 times over, right? But how do we actually clarify or tell Ruby what it is that we want to do a certain number of times? That's precisely what the block does in this specific method call. So how the block operates and what it does is going to depend on what the method is. In this case, when we're dealing with the times method, it's going to specify what we do that number of times. In this case, what we want to execute 10 times over. There are two syntactical ways that we could write a block, one with curly braces and one with two keywords called do and end, and I'm going to introduce both of them right here. Let's begin with curly braces. I'm going to open up a pair of curly braces right here. Those are those little squiggly ones, and as soon as you write the first, Adam is automatically going to fill in the second one for you. And everything that I write in here between my curly braces represents the body of my block. So here I write what I want to do, in this case 10 times over. So I'm going to write puts, and let's say Boris is awesome. All right, so this part, beginning with the curly braces and everything inside it, is the block. The block is attached to a method call. It is not the same thing as an argument, right? But it is attached to a method call, and it clarifies how this method is going to operate. And what are we going to do? 10 times over, we're going to puts out the string Boris is awesome. When I execute this, you can see that Boris is awesome is going to be output 10 times over. If I change this number up front to something else, like a different fixed num like 3, well, predictably, this is going to happen 3 times now instead of 10, but the block's content remains the same, so it's simply going to repeat that code, puts Boris is awesome 3 times over. Let me go ahead and comment this line of code, and we're going to repeat it using the alternate syntax for creating a block. I'm going to do the exact same thing, 3.times. 3 is my fixed num object, times is the method that I call on it, and what I provide after is called the block. Up top here we have our very first option with curly braces. Our second one is with the keywords do and end, and the traditional syntax for doing this is to write do immediately after the method call, skip a few lines, and then write end right here. Now, the general best practice is to stick with curly braces whenever we have a one-line block. So in this case, we only have one line that we want to execute. So we were able to structure everything within one line, and thus we used curly braces. Do end is designed to be used whenever you have more than one line of code that you want to execute within each block. So in this case, we're specifying what we want to do 3 times over. So let me put multiple lines in here. I'm going to put Boris is incredible. And right below that, I'm going to put I'm having so much fun learning Ruby. So here we have a body of the block that is 2 commands long or 2 statements long. So we've satisfied that best practice of having a body here between do and end that is more than one line long. Now this is just a best practice, right? So you can have a do end with only one line of code, and similarly you can have curly braces with multiple lines of code between them, but the best practice is to stick with this design of curly braces for one line, do end for multiple lines. Otherwise, this is still a block. So everything here between the beginning of do and the conclusion of end is a block, and this is what we're going to execute 3 times over outputting these two strings right after the other. So when I execute this 3 times over, we're going to output Boris is incredible. I'm having so much fun learning Ruby. You can see it repeated right here in the Atom Runner output. Now this is where it gets kind of tricky because blocks can also include something called block variables. The block variables is a temporary variable that's going to represent something within the context of that block's execution. And here's how we create a block variable. We do it in between vertical pipes. So here I'm going to add 2 vertical pipes. This is the syntax, right? And in here, I'm going to specify a block variable. Now, depending on what method it is that you're calling, what the block variable or block variables represent is going to change. In the context of the times method, what we provide to the block variable is going to represent the number of the iteration. So for example, I could write something like count right here in between my vertical pipes here. Now this thing in here, the block variable, can be whatever name we want. We can call this count, we can call this I, we can call this iteration, we can call it Boris. Basically, any name that you want to provide is fine here as long as you're not using some kind of default Ruby keyword, okay? So in here, I'm just going to stick with count. All right, and count, as you can see from the fact that we ran this a few moments ago without it, is optional. So we don't have to actually use it, but in this case we can. And we provide it within the vertical pipes, and now we have access to that block variable in the context of the execution of our block. So what I can do here is put this, puts, we are currently on loop number, and interpolate the current value of the count block variable. Now Ruby in this case is actually going to start counting at 0, so our count is going to be 0, 1, and 2 in order to make this work 3 times over. So when I execute this, I'm going to get, we are currently on loop number 0, the count begins at 0, and then we're going to repeat the 2 lines below, and then it's going to begin again, executing the entire content of the block's body, and then we're going to get to we are currently on loop number 1, followed by we are currently on loop number 2. Now just to prove to you that our block variable name can be anything that we want, I can replace this with something like I, replace this with I as well, and you can see here no problem, right? So this is just our own name that we're assigning, and what it represents is going to depend on what method that block is being attached to. Within the context of the times method, it represents the current iteration, keeping in mind that that iteration starts counting at 0, okay, not at 1. Another thing to watch out for here is the block variable is only going to exist locally within the block's execution. So if I try to output I after I'm done iterating, it's going to be trigger an error. I is not going to exist except for within this block when it's working with iterating and representing the current count. If I try to output I after, I'm going to get undefined local variable or method I, because I is not going to exist at this point on line 9. It's only going to exist temporarily during the context of execution of this block. So block variables are designed to be temporary. They're simply to be used for the execution of each block. Now, if I wanted, for example, to have this running count start at 1, I can do something like this. I can simply add I plus 1. I'm going to get rid of this put statement of I because I is not going to exist. And in this case, you can see we're going to get the same result, except it's going to say we are currently on loop number 1, followed by 2 and 3. That's just a different way of representing it. But again, what the block variable represents is simply the current number or count of the iteration. The process is exactly the same if we use curly braces. So right here, I'm going to comment out my code between lines 3 and 7. I'm going to uncomment my code right here. And in this case, if we're using curly braces for a one-line block, I simply put the block variable after my opening curly brace. So in here, I can do something like this, count as the name of my block variable in vertical pipes after my opening curly brace. Here I write what I want to do. In this case, I'm not actually utilizing count, so it's kind of pointless. So let's do something like we are on number count. I'm going to interpolate that block variable. And here you can see we're going to get, we are on number 0, we are on number 1, and we are on number 2. So again, count the block variable is representing the same thing. This is just to prove to you that block braces versus blocks with the do end don't make any difference. It's just a syntactical difference. It's a variation, but they both function the exact same way. And just like with do end, if I try to output count afterwards, I'm going to get an error because count is a local variable. It's a block variable that is only limited to this execution. As soon as the block is done, it ceases to exist entirely. Okay, so this has been a very quick introduction to blocks. Hopefully you're getting the general big picture overview. I know the syntax will take a little bit of time to get used to. So here's what I recommend. Copy your code or copy the current code that you have right here and comment it out because I'm going to clear mine. And I'm going to offer you a challenge right here. Let me go ahead and clear my code. The challenge is this. Use the times method to output the first 10 multiples of 3. What that means is the numbers 3, 6, 9, 12, and so on, all the way until we get to 30. Okay. Remember that the first loop is going to start at 0 when you use a block variable. So you'll have to add 1 to each block variable as you proceed through the iteration. But otherwise, the process is going to be the same. Be clever. Take a second to pause the video and see if you can figure out how you can output the first 10 multiples of 3, starting from 3, using something like the times method and the attachment of a block with a block variable. I'll see you in a few seconds. Okay, here's how I solved this problem. Keep in mind that you can use either do end or curly braces. Whatever you did is totally fine as long as it works. In this case, I'm going to use do and end because I'm going to make a couple lines here. So let's say I begin with the number 10. That's my fixed num object. It has an available times method. That method accepts a block. So I'm going to create a block with do and end. Of course, the alternative here is curly braces on a single line. This is exactly the same thing. There is no technical difference. It's only a syntactical difference between those two. After do, I'm going to write my vertical pipes to specify that I'm going to give a variable name to my block variable, which is only going to exist within the execution of the block. And this time, let's say I do something like count, keeping in mind that count will start at 0. So I have to remember that. And what do I want to do? I want to say, all right, let's show the next multiple. Of course, this is not required. This is just because I have do and end, and I want to write an extra line here to make this a proper multi-line block. And here's where I can actually output it. So here's what I can do. I can do puts, and in here what I can do is interpolate 3 times whatever the current count is. But keep in mind, if I do this currently, let's in fact take a look at what's going to happen. We're going to have something very close, but we're going to start counting at 0 here. You can see because count starts at 0, it proceeds all the way to 9, 0, 1, 2, all the way to 9, which is technically 10 iterations, right? But in our case, it's going to give us 0 through 27 instead of 3 through 30. So what I can do here to make this work is to add +1 here, and to prevent the operation from first multiplying before it adds, what I want to do is this. Wrap this in parentheses. That way, count is going to start at 0. It's going to have 1 added to it to get 1, then multiplied by 3 to get 3, and then so on and so forth. It's going to repeat the process starting at 3, then 6, then 9, as count increments by 1 every iteration, until we get to 30, which is going to be 10 iterations. So here you can see we're getting, all right, let's show the next multiple, 3, 6, 9, 12, and so on. If I wanted to do this with a simple curly brace, I can do it like this, 10 times do, or rather not do, but curly braces, count. I'm going to copy this code right here because that's the only one I need. There we go. I'm going to comment out this code so we don't get confused about what's doing what. Save this, run this, and you can see we're getting the exact same result. It's outputting the first 10 multiples of 3, except we're using the curly brace syntax here to create a block. So again, to iterate, curly braces versus do end, no difference technically. Two ways to accomplish the exact same thing, to create a block. Within the block, we can specify an optional block variable that's written in between vertical pipes. That specifies something that's going to change on every single iteration. Blocks are specifically designed to be attached to method calls. So this thing right here, the block, cannot live by itself. It can only live within the context of a method execution. In this case, the method that the block is attached to is times. Times is called on a number or an integer, and it does something that number of times. What it does is what we specify in the actual block itself. So a block is sort of like an addendum. It adds a little bit of an add-on that clarifies how the method is supposed to run. Because the times method fundamentally says do something this number of times, but what it does, that additional clarity, that additional clarification, that additional specification of what the actual process is what we provide in the block, again, between either curly braces or do end. So that's a very quick introduction to blocks. We're going to see a bit more or a few more examples in the upcoming lessons, but hopefully this is giving you a general sense of what purpose they serve. The syntax, again, will take a little bit of time to get used to. I'll see you in the next lesson.